In this section, we'd like to talk about advanced opinion summarization techniques while sharing up challenges and opportunities in the field. Those four challenges, scalability, faithfulness, controllability, and multimodality, have many open questions in opinion summarization. We go through each challenge one by one. The first challenge is scalability. In practice, one entity may have hundreds of reviews. A summarizer has to take many reviews as input to make a summary. The model should be scalable, especially with respect to the number of input reviews. Autoencoder-based models are scalable in one sense. Those models, such as MinSum, can encode input reviews in parallel. Then the average latent vector is decoded into a summary. However, one study showed that averaging more latent vectors tend to create more generic summaries, which can be true for any entities. The issue is called latent vector degeneration. The study shows that the L2 norm of an aggregated latent vector gets smaller as more latent vectors are averaged. To address this issue, one idea is to filter input reviews so that the average latent vector will not be shrunk. COPE, which was mentioned in the previous section, selects input reviews so that the word overlap between a generated summary and the input reviews is maximized. This simple idea helps the summarizer to generate more entity-specific summaries. Using intermediate representation is another way to avoid the vector degeneration issue. For example, OpinionDigest, which uses opinion phrases as an intermediate representations, cluster opinion phrases extracted from input reviews before feeding into the encoder-decoder model. This aggregation operation before encoding does not cause latent vector degeneration and can be easily parallelized. So this approach is scalable to the number of input reviews. A more sophisticated end-to-end approach is to implement a review selection function inside the summarization model. SILSUM learns a selector component using a latent variable modeling, so the decoder can condition on a smaller subset of reviews in the summary generation phase. The SILSUM paper conducts experiments using a benchmark that has more than 300 input reviews and confirms that SILSUM effectively generates summaries from such a large number of input reviews. Let's move on to the next challenge, faithfulness. Summaries should be faithful to the input reviews. However, neural abstracted summarization models are known to have the hallucination issue. That is, the summarizer generates something that does not exist in any of the input reviews. In this example, content colored in red does not appear in the input reviews. This would be a big problem for real-world applications. How to address hallucinations is an active research topic in summarization, and it is a big challenge for opinion summarization as well. One approach is to implement a component that helps guide a summarizer to generate something that is aligned with the guidance. PlanSum, which is covered in this tutorial, has a content planning function, so the decoder takes a content plan into account and generates a summary accordingly. With this approach, PlanSum can generate summaries that are aligned with input reviews. Another approach is improving the synthetic training data creation step. ConsistorSum creates synthetic training dataset by selecting a pseudo summary that is aligned with input reviews with respect to semantic similarity, sentiment polarity, and aspect category distributions. With this method, ConsistSum can create a high-quality training data, which can be used to train a summarization model. Then ConsistSum uses the collected training data to fine-tune a T5 model while training aspect and sentiment classifiers in the same model in a multitask learning manner. The next challenge is controllability. In practice, users may want to get summaries that focus on specific aspects and sentiment polarity in their minds. Here are some examples made by OpinionDigest, which can create controlled summaries by filtering input opinion phrases based on the sentiment polarity. Different colors highlight different pieces of information. As we can see, those summaries focus on positive or negative opinions. The same technique can be used to make summaries that focus on certain aspect categories, such as staff or food. ASUM uses synthetic training data that are enriched with aspect controllers, so you can train a summarizer that takes aspect controllers as additional input. With this model, the user can give aspect controllers as a query to make a summary that focuses on the target aspects. A similar idea is using self-sum. This method trains a transformer model that takes control code in addition to customer reviews, so it can be used to generate controlled summaries. CondensSum implements a condensed abstract approach. The condensed model encodes input reviews into condensed vectors, and the abstract model learns to fuse condensed representations to make a summary. If the user wants to make need-specific summaries, they provide background reviews as examples, so the abstract model appropriately fuses condensed vectors for need-specific summaries. Qt offers a slightly different solutions for controllable summarization. Qt learns to encode sentences into different codes in the latent space, which are corresponding to different aspect categories. In the summary generation phase, we can use aspect-specific seed words to select latent code that is corresponding to the target aspect, so the sentence can be used for summary generation. The fourth challenge is multimodality. So far, we only talk about opinion summarization models that takes textual reviews as input. However, text is not everything. Many reviewers upload photos that often support or complement the textual information. Also, many reviewers assume that the user knows about the general information of the entity, such as location or restaurant types. Therefore, taking other modalities into account is an important challenge for opinion summarization. MultimodalSum is an opinion summarization model that is designed for multiple modalities. In contrast to existing models that only consider text-to-text setting, MultimodalSum considered additional non-textual information, images and tables as part of the input. In the pre-training step, MultimodalSum trains an encoder-decoder model based on input reviews and pseudo summaries. Then it trains additional encoders for images and tables while sharing the same decoder for summary generation. Finally, it combines all the encoders and the decoder to make a single multimodal opinion summarization model. there are more challenges where we don't have good solution yet. Multilinguality is another important challenge, which is often overlooked. Almost all publicly available opinion summarization benchmarks are in English. There are more non-English speakers than English speakers in this world. We should study if existing solutions can be used for other languages. For example, customer reviews written in other languages should reflect cultural differences. This would be an interesting challenge for opinion summarization. Also, cross-lingual opinion summarization, where the input and output are in different languages, is an interesting problem. A recent paper has created a Wikipedia summarization benchmark, which consists of document summary pairs written in different languages. With this dataset, researchers can tackle a cross-lingual summarization task where the input is, let's say, in French, and the output is in German. Personalization is another important future work. Future opinion summarization models can transfer writing style, and solutions for controlled summarization help generate summaries that are aligned with user intent. However, none of the work takes into account user preferences and profiles to further tailor summaries. For example, different users should have different standards. Some users may be more strict about the quality of food, while some users care about more the service quality. Personalization beyond the style transfer and control summarization is a big open problem in the opinion summarization. Techniques that have been developed in information retrieval research should be useful to study this topic. Lastly, and most importantly, we need more annotated resources to tackle those challenges. Recently released benchmarks such as SPACE and MultimodalSum aim to create more realistic datasets by collecting reference summaries for a larger number of input reviews. SPACE also collected aspect-specific reference summaries, so researchers can evaluate solutions for aspect-controlled summarization. We should create more benchmarks in a variety of domains, in the multiple modalities, and in different languages. Making benchmarks that are aligned with those challenges is essential to accelerate opinion summarization research. Let us make concluding remarks. This tutorial covers a line of work in opinion summarization, which takes one step beyond existing efforts in opinion mining. Different from opinion mining, which focuses on creating structured information, opinion summarization aims to create textual summaries from multiple customer reviews. The two key challenges for opinion summarization are the lack of annotated data and modeling multiple reviews. To address those challenges, modern opinion summarization solutions take different approaches. First, autoencoder-based models use self-supervised learning framework, which leverages unannotated customer reviews to build summarization models. Second, synthetic dataset creation methods create pairs of input reviews and pseudo summaries, which can be used to train summarization models. Third, in case few training examples are available, we can use a featured learning approach to train summarization models. In addition to many interesting research opportunities, we'd like to mention the use of opinion summarization for real-world applications. As more customer reviews become available, users need assistance to make decisions by digesting information spread over tons of customer reviews. opinion summarization offers practical solutions which can have high impact on the business side as well. Many of the research papers that we share in this tutorial list their code and trained models. So you can try out some opinion summarization models for your problems. We'd like to emphasize that opinion summarization is a very important research topic from both of the research and business perspectives. We have covered existing efforts and challenges in opinion summarization. We want to conclude this tutorial by posing a question: what will beyond opinion summarization look like? Thank you for your attendance. We hope you enjoyed the tutorial, and we'd like to take questions.